How you going, guys? Curtis from Cutting Edge Engineering. So today we're going to give you a tour of one of our new to us machines, which is a Kitchen & Walker Type P1 facing borer. So I don't really know a great deal of history about this machine. It was made in Halifax in England. Kitchen & Walker are more known for their radial arm drills. I have operated one of those at a company I used to work for, but this is the first facing borer I have ever seen in person. From what I can figure out and what I've read on the internet, they were basically used for facing large parts like big water valves, gas valves that needed a perfectly machined surface in order to seal. So I don't know the exact year the machine was built. I'm going to assume 1950s to early 60s because a lot of the fasteners have the same sort of shape as our Klopp shaper and our Hydroptic number 6, and they are both 50s model machines. So when we first got the machine, I plugged it in just to see what it could do, powered it up, and we found everything was spinning backwards, so the polarities were backwards from my shed to where it came from. We got those switched over, plugged it in, and everything worked. The rough dimensions on the facing borer, it is 2.1 meters tall, it is 3.5 meters long, 1.8 meters wide, and it weighs about 6 tons. It is quite a heavy machine considering its overall size, but back in the day they built stuff so it would not flex. And something else I noticed, there is a machined surface on the end of the bed with 6 threaded bolt holes in it, which I'm going to assume it used to be a tailstock plate. So if you were doing a deep boring job, you could mount a bar in the machine and then support it out here on the tailstock. The length of travel for the head going all the way to the bottom to all the way to the top is 420 mil. The travel on the table from left to right is around about 600 mil. You do have to wind that one manually. You would generally use a handle, a square drive handle, but I didn't get that with the machine, so I'm just going to use a shifting spanner until I get around to making a handle for it. And every rotation of that is 1/4 of an inch of travel on the table. And the travel on the table in and out is about 800 mil. The machine has a main table. It is 1070 mil wide by 910 mil long. On top of that table, we have a manual rotating table. It is 760 mil wide by 760 mil long. So the top table rotates 360 degrees, but it is able to be locked in 90-degree increments. So whatever's on there can be faced, turned 90 degrees, faced, so on and so forth. The table is locked by 2 clamps. And 1 locking wedge that fits into the slots on the rotating table. So the way you rotate the table, that's all manual, it isn't powered. So I just learnt something about my machine that I didn't catch on to when I started looking over it. So there are the 4 positions to go 90-degree increments, but there are also a few other positions here that the wedge will fit into to set different degrees on the table. I was not aware of that. I don't know what they are, but you could easily throw something on there to measure them out. So there you go. So that's the basics of the table. Let's get the machine turned on and show you what else it can do. Come on, stumpy jumper. Sit, sit, sit.
Sit. Sit. Lay down. Good boy. Oh.
Right, so the travel of the table in and out can be controlled 3 ways. And to choose which feed you want to use, it's just this handle here, which is the main part of the gearbox. It can be controlled by hand. It can be rapid fed in and out for when you're doing setups, or it can be set to a feed rate with 3 different speeds. You can go 1 inch per minute, 1/2 inch per minute, or 1.5 inches per minute using this lever. The hand wheel is a direct drive straight from the hand wheel straight on the lead screw, so you can crank that as fast or slow as you like depending what you're doing. Every rotation of the hand wheel is 1/4 inch of movement on the table. So the rapid traverse on this is 1 speed and 1 speed only. So I've now set the gearbox to rapid traverse, but when you're using rapid traverse, you do need to remember that the 2 buttons you have up here on the control panel also control the feed. So at the moment, that gearbox is direct drive to the lead screw. So you need to push the in button and then there is your out button. But when it is feeding, they are opposite. So the rapid traverse does run very quick on this because it is now a direct drive through the gearbox. If you are at your end stop and you push the button the wrong way, you will probably break something. We'll just show you how quick it actually takes off. Something else to watch out for when you are using the rapid traverse is the hand wheel can be locked in order to feed it, and then it can be brought out to disengage it. You need to disengage the hand wheel because I pushed the button and it took off and it nearly took out my knee. So good rule of thumb is disengage the hand wheel when you are using the rapid traverse. As for the 3 feed rates on the table, they are also controlled by the buttons up there, but you also need to lock it into gear, and then you can select one of the 3 speeds for whatever job you are doing. So it's set on the slowest feed rate, which is 1/2 inch per minute. Now we need to remember our feed is opposite. So now we're going in. Now we'll change it to 1 inch per minute. And the fastest is 1.5 inches per minute. So that's the feeds and speeds for the table in and out. Now we'll show you the head movement up and down. You do have 2 buttons there which will rapid it into position. There is only 1 speed for the up and down when you are using the buttons. Then you also have a handle up top directly to the gearbox, so you can then make fine adjustments to bring the head into alignment or up to a face. So I'm assuming this will be in thousandths, 1 to 34, 1 full rotation, 34 thousandths of an inch. So another fun thing to remember is you don't want to leave the handle on that wheel and push one of those buttons, because it will fly across the workshop. So by the look of how much damage is on this particular handle, I'd say it's flown a long way a few times. The last thing on the machine we haven't shown you yet is the faceplate and its operation and the different speeds you have for the rotation of the faceplate. That is all controlled by 2 levers over here. So 2 levers give you a combination of 9 different speeds. It goes from 17 RPM to 216 RPM. And the faceplate only rotates in one direction. So we'll set it to its slowest speed, which is 17 RPM. So the inner lever needs to be set to C, which it is, and the outer lever needs to be set to B. And then you push start. And the fastest speed, 216 RPM, we will set the inner lever to B and the outer lever to A. on the faceplate rotation, there is a start and a stop button, but you can actually inch the faceplate around just by touching this button. So for safety reasons, we're going to slow it right back down to 17 RPM, and then we'll show you how the faceplate advances when it's in its facing operation. There are a couple of ways you can do that. You can feed it by hand, which is done via this wheel here. You can also auto feed using the selector. Selecting feed forward will feed the faceplate out. And there is one speed for that. It is 1/32 of an inch or 0.6 of a mil per rotation. So that's taking too long. We're going to speed it up to 72 RPM. The speed of the feed reverse is 1/16 of an inch or 1.6 mil per rotation. Or you can set it to no feed while the faceplate is spinning. The travel of the faceplate is 250 mil, and that is in each direction. The chuck of the faceplate is 500 mil in diameter. Depending on how you set your tool up on the rotating table, you could face a job 1 meter in diameter. If you were to have clearance in the front of the bed, you could swing a tool at 1.6 meters and face something that diameter. So as you can see there, that is the faceplate fully extended. So if that tool was mounted down there, that is a very big swing that this machine can achieve. It also has a safety for both directions of travel. You have a limit switch over there, so if it does start to get out to those larger diameters, it doesn't smash the gearbox inside that's driving the faceplate. It simply shuts down the power and the machine stops. So the horsepower on the electric motor side, we have a 7.5 horsepower motor that drive the faceplate. We have a 2 horsepower that drives the feed for the gearbox that feeds the table in and out, and a 2 horsepower up on top to lift and lower the head. So back here is the electrical cabinet. It looks really clean and tidy. It doesn't look like anyone's got in there and done anything dodgy. Looks that the machine has had a few upgrades throughout its life. I mean, I didn't know that there was insulation tape back when these were made, or these crimp-on terminals, but it looks like a few things have been swapped out to some later and upgraded components. Oh, hang on, here we go. This is the first time I've ever seen these plans. I didn't actually bother to even open the electrical box when I first got the machine. We simply changed the polarities on the plug. So I didn't know they were there, but it's actually a hand-drawn schematic of the electrical system of the machine. Being that it is hand-drawn, it means it's quite dated, just like the jig borer, because a lot of her information is also hand-typed and drawn. The machine also has an oiling system which oils the bed, so that's just a couple of pumps, runs through the copper pipes out into the ways to keep them lubricated so they don't start to grind themselves apart. There is no auto lubing system up here. You just open up these little caps, put oil in there, close the lid, and that feeds the ways for the head on its movement up and down. There is also grease points in the faceplate for greasing that, and you also have greasing and oiling points on the gearbox and the hand feed for the table in and out. So there is a few grease nipples around to be greased, a few areas for it to be oiled, and the main oiler for the bed. So why do I even have this machine? I saw it advertised and thought, I have got a brilliant idea for that. Sight unseen, I purchased the machine on the spot. Pretty easy to take the gamble on it because it was only $4,000. Considering what the machine weighs, I'd get that money back in scrap if it turned out to have any sort of problems that I couldn't repair. When I first saw the machine, I was a little bit confused because I assumed it was a horizontal borer, just its general shape and structure. And I was wrong, it is a facing borer, which is no big deal. I am in the market for a horizontal borer, but at this stage, the price here in Australia and their condition is just ridiculous. They're asking a lot of money for machines that have done a lot of work and have a lot of problems. Rather than go and buy a clapped out horizontal borer and have issues with it, I spent $4,000 on this and I can make this do what I would normally do in a horizontal borer. A couple of differences between a horizontal borer and a facing borer. Horizontal borers have an extendable quill that comes out of the face of the machine, and you can use that for drilling, tapping and boring. One of the other differences is the tables on most horizontal borers are powered and they can be rotated 360 degrees, and every axis is powered on horizontal borers. So what am I going to be using this machine for? Well, after I do the modifications I need to do, it will mainly be used for doing our big suspension struts that I would generally do with our line boring machine. So a lot of the really big suspension struts we do, they have got a very wide snap ring groove or even a grease groove in them. And to try and achieve those grooves with a single cut can be quite hard to do with a line borer. Yes, they can achieve it, but they are a very expensive machine, and I would rather not flog it to death. So when this became available, I knew exactly what I was going to use it for. We will do whatever modifications we need to, and it will then take the load off the line borers on those bigger jobs. And some of the modifications I will be doing to this before it goes into service is the head is actually not high enough to do a lot of our bigger suspension struts. What I need to do, I need to build a spacer plate to go underneath the column to lift it up in order to get the right center height to do a lot of our bigger struts. Some of the other modifications I'm going to be doing, I do need to make all new tooling for it. The machine didn't come with any tooling at all. It did come with this mount that was sitting on the bed when I got it, but I don't think that's standard. It looks to be someone's made it. We will end up making our own tooling for this in order to do the jobs we need to do. I will also be putting some sort of powered device onto the table so I can then traverse it left to right using, say, a table feed off a milling machine. So I'll do that, and I will also be putting digital readout on this. So even though we're going to be doing a lot of modifications to enhance this machine, I'm not going to do anything that can't be undone. So everything I do to it will be able to be removed in order to put the machine back to its standard configuration. This machine build will be a bit of a series. So the first thing I need to do, I need to make the spacer blocks to go under the column. Once I've fabricated the spacer block, we'll be using our Hydroptic number 6 jig borer to do the facing. So keep your eye out for that. So that's the tour of the machine. We've showed you what all the functions are, what it can actually do. What we're going to do now, I'm going to set up a piece of material and do some test cuts. So because I've got no tooling for the machine, I did go ahead and make up a boring bar. It is a piece of 80mm chrome bar and it suits the adapter that came with the machine. I did put a slot in the end of it to hold a 12mm tool. Right, so the piece of material we're going to be doing the test cuts on today, it's a piece of 200 by 245 hone cylinder tube. So it's about an ST52 grade or pretty close to a 1045. This will be good to test on because it is a very similar grade to the jobs we'll be putting in this machine. So I've got that set up now. I've got it centered as close as it needs to be for what we're trying to achieve with our test cuts. I've also gone and locked the faceplate, because if you don't lock that, they tend to chatter and move around. So I just locked it by the two big locking bolts. I've also locked the head from going up and down and the table from moving side to side. Right, so what we're going to be doing now, I'm going to be taking about a 2mm depth of cut. The tool I'm going to be using is a TCMT insert. The table is going to be moving into the machine at 1/2 inch per minute, and the RPMs I'm going to run at, I'm probably going to start in the higher range at about 160 RPM. The reason I'm not starting at, say, 17 RPM is because the table is moving at 1/2 inch per minute, regardless what speed the faceplate is doing. That would just be far too much load on the tool. Those lower RPMs would be better suited for a facing operation while the table is not moving. Now that that's all done, let's see what this thing can do. Things weren't standing overly great there for a second, so I did stop it. So we're going to change out this TCMT 12mm holder. It's not really achieving what I want it to a ECGT line boring insert and tool holder, which is a far better designed tool and insert for boring. I have reduced the depth of cut to about 1.5mm. We will feed that through and see how that goes. Righto, so that went really well. I'm really happy with that surface finish. That's sort of what I'm looking for the jobs this machine's going to be doing. So what I'm going to do now, I'm going to advance the tool to 1mm depth of cut, leave the RPMs where they are, but I'm going to increase the feed rate up to 1 inch per minute. Righto, so that was going really well. The surface finish is still very good. And then I pushed the wrong button and I actually drove the tool into the bit of hollow bar I'm boring. So I pressed the wrong button and the table fed the wrong direction. And that's the issue with having two buttons that do four things. I did make a mistake, I did break an insert, but no big deal. That's what testing is all about. I've changed out the insert in the tool holder, the one that I just smashed. I'm really happy with the results we have achieved so far, but curiosity's gotten the better of me. So I'm going to increase the RPMs up to its maximum, which is 216 RPM, and then I'm going to put the table to its maximum feed rate, which is 1.5 inches per minute. And we'll see what sort of results we achieve with that. Right, so that wasn't the last one. What I am going to do, I'm going to run it at its maximum RPM and its slowest speed rate, see what finish we can achieve with that setup. Righto, so that achieved a very nice surface finish. I'm very happy with that. The RPMs are a little bit high to be running the bar offset to the faceplate. When we do end up making tooling for it, everything will be central to the faceplate and we will simply mount a boring and facing head on the end of that for doing all the fine adjustments. But for the time being, I'm really happy with the results, so we're going to leave it there. There's not much information out there online that I can find about this machine. So if anyone out there in the world who's watching has operated one or has seen one in person or has any information on them at all, I'd like to hear from you. So that's a tour of our Kitchen and Walker facing borer. Thanks for watching. On straight? It's got to be on straight. I see how I look on screen and it's like my hat's like that. That's how bad out of whack it looks.
It's not though.
It needs to be on straight. Symmetrical.
It looks fine.
Fantastic. It was made... Fuck, I should have put that look at it. Now we'll show you the up and down motion of the... So the machine has a main table. It is 900mm long by 1 metre wide. Oh, fuck, hang on. The machine has a main table. The machine has a main table and it is a... Fuck me. The machine... Oh, hang on. Fuck. How did I start that? I lost it. Oh, fuck me. I lost it. Right, so that's how... Oh, wait, we're talking about that bit. Fuck. On the facing operation, and that is the face of the faceplate coming out when it's doing a facing operation.
Wow.
The only difference is the feed forward is half as far. Oh. Fuck. And that will put weight. I just spat on you. It looks to be early 50s to. Oh, fuck off. Really. Fuck off. I'd like to hear from you. Fuck off. Fucking wet weather warriors, man.
Has to be a Commodore.
It is a Commodore.
Table movement. Jesus. Don't stand too close. Jesus.
Can you imagine if that wheel had the hand crank wheel on it, like the hand crank handle like the lathes have on it? It'd throw you
It is
across
perfect knee height.
Like, if it got under your kneecap, it would force you to knee yourself in the face.
What happened?
I fucking got my finger jammed in between that fucking lever and that lever. Surprise, motherfucker. One of the biggest letdowns with this machine is everything is read and measured in bananas. So, because I'm here in Australia and we speak English, everything will be converted over to metric.
Oh no! Hey, sit down. Oi, sit. Lay down. Lay down. Hey! Can you dress yourself a bit better, please?